Hi guys, you may remember that where we left off last class, I was trying to find the average time to find the first multiple 3 in a list of random integers. If you want to be technical, with replacement, with repetition, so you can have the same integer twice. And they're more or less uniformly distributed. Now, you could have a list with no multiples of 3, or you can have a list which is the worst case, one of the worst cases, or it could show up the first time. So that would be the best case. But what is the average case? Now, I came up with math that looked like this, and then I got tangled up in the algebra. So I'm going to show you that this is approximately O of 1, but I'm not going to use algebra, at least not initially. I'm going to use pictures. So this is how we're going to show it. We're going to start, okay, so we have 1/3 of the time. It's the first guy. So I'm going to build a rectangle of height 1/3 and width 1. And the area of that rectangle will be how much work we do when it's the first guy. That is 1/3 of the time we do 1 work. So I'm going to go in and draw a rectangle of height 1/3 and width 1. Well, I put that down. I need a little room here. So this is height. I'll just draw that 1 over. Be good. 1 over 3. Being annoying. Really doesn't want to draw. Would you believe 1 over 3? Let's write it. Try it this way. 1 over 3 and width 1. And so that captures. Now, then 2/3 of the time we go on to the second item and we look at it, and 2/3 of the time and 1/3 of that time it's the second item, so it's 2/3 times 1/3. So we could call that 1/3, or we can call this guy 1/3 times, and let's math this guy up. 1/3, or call that 1/3 times 2/3 to the 0. Okay, so I'm going to move that guy up here. 1/3 times 2/3 to the 0. Okay, that's the width of that guy. Another way of saying 1/3. Now, so I'm going to draw a rectangle of width 2 to represent when it's in the second place. And that'll be 1/3 times 2/3 to the 1. That is, we have to look by 1 and go there. So, I'm going to draw a second rectangle. Actually, let's go into draw rectangle mode. So this one could be 2/3 as high as the previous one, but twice as wide. Make that just a little bit bigger. 2/3 as high, twice as wide. I'm going to make a kind of step structure out of this. So this is going to go, so this guy will be, I'll go away. Now, there, you want to see, oh, got my stocks. Anyway, go away. Alright, now, so, give me back my thing. Okay, so, type, I'm going to take this guy. This is going to be, so the height of this guy is going to be 1/3 times 2/3 to the 1. And this whole thing, I'm going to make a little smaller. Okay, now, and so this guy is of length 2. So this part is of length 1 over here. And so that's 1 plus 1 is 2. And then we're going to make another step on this guy, building this little staircase, but each step is 2/3 smaller, because each step I have to go 2/3 times 2/3 to get to the next point, and then it's 1/3. So I'm going to draw yet another rectangle. This is 2/3 of as high as the previous rectangle, and one larger. And so the height of this guy will be, so let's make this guy a little smaller. Yeah, it's got to be a little smaller. And then and so this new guy is going to be 1/3 times 2/3 to the 2. And so each of these is 2/3 the previous one. The idea, and this is another one, and each one is one wider than the previous because each represents that much more searching. One more step, you do one more step 2/3 at a time, you do one more step 2/3 at a time. Now this keeps going down, okay? So we go dot, this keeps going dot, 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 until, in more or less infinitely. And so, well, until we get to n. But to keep it simple, I'm going to assume it just keeps going. Now the idea is, eventually, if it was an infinitely long thing, eventually you would find, simple, eventually you would find, right, you would eventually, if it's an infinitely long list, eventually you find a multiple of 3, or you do infinite amounts of work. But the basic point is this whole thing over here. Let's see if the drawing thing wants to work for me. This whole guy, each of the steps a bit longer than the previous until going to infinity. So it goes step, 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 adds up to 1. Whole thing is 1. Right? So now, and so you can see how these rectangles, this is going to be 1. So what I'm going to do is take, so we can, I can draw some more rectangles if you want. Let's go back here and, right, so imagine all of these rectangles. I'm not going to keep on drawing the one, I think you got the pattern here, so here it goes. This is an even narrower rectangle, about 2/3 of that one, and so on. And another one that's even bigger. Okay, that's 2/3. And the main point is that this each of the vertical represents how long it takes, how often you find it on this location. Now the interesting thing is, and this thing keeps going down. Cool? Now the interesting thing is, so if we go to infinity, that comes out to 1. Now what I'm going to do is just rearrange these rectangles as vertical rectangles. So I'm going to take this guy and draw a vertical line, and this gives me, it doesn't look like it, actually it probably does. Let me do it a little better. This is going to give me something like a square, 1 by 1. Now, this was 1/3. So this gives me a square, a rectangle. Give me a stop that. Where are you? And this is going to give me a rectangle of 2/3 by 1. So that's, this one is going to give me a rectangle of 2/3 squared by 1. Because each of these rectangles, the height is 2/3 of the previous, because 1/3 at a time, it stops. So I get a series of rectangles. So this guy, so if I have an infinitely long list, the average time it's going to take is going to be, it's the same area, right? It's the area of this structure, and it's going to be equal to the sum of 2/3 to the n. Now, so this is the sum of a geometric series. Now, the sum of geometric series, the sum of 2/3 to the n from 0 to infinity is equal to 1 divided by, why are you being annoying? 1 divided by 1 minus 2/3. Yeah. Okay. Now, okay, so let's take this guy. I made a mistake there. 1 divided by 1 minus 2/3. There. So, equals 1. Okay, be that way. Now, that's 1 over 1/3, which equals 3. So the average case for finding a multiple of 3 in an infinite list is 3. Which means in a list of size n, it's less than 3. Which means this is going to be O of 1. And so that shows that, okay, since finding a list of size, finding a multiple of 3 in an infinite list has an average time of 3. Finding multiple of 3 in an finite list is O of 1. And that is the answer to that problem.